This video is talking about perfect square and square roots. So we've already talked about exponents and powers. And one of the exponents that we talked about was to the second power, right here, to the second power. Okay? We also call that squared. So 3 to the second power would also be 3 squared. Okay, so when an integer, like the number 3, is multiplied times itself, 3 times 3, we call that a perfect square. For example, 3 squared means 3 times 3, which is equal to 9. So our perfect square here is 9. Okay? When an integer is multiplied by itself, that solution is called a perfect square. All right? So you're going to be responsible for memorizing a lot of the most common perfect squares. 1 squared, 2 squared, 3 squared, 4 squared. Okay? It's going to help you in several concepts when we get to Pythagorean theorem, which is figuring out the sides of triangles, right triangles. And that has to do a lot with squares. So if you automatically know what 3 squared is or 4 squared is, you'll be able to do the Pythagorean theorem problems a lot more accurately and a lot more quickly. Okay. On these examples, we're writing each expression in standard form and then simplifying. So standard form here is I'm going to write out my product of my factors. 9 squared would be 9 times 9. And then what I'm going to do is multiply 9 times 9 and get 81 for the simplify part. Okay. 81 is my simplified expression. I'm going to have you do number 2 by yourself. We've talked about negatives and exponents already. For number 3, when we use decimals, instead of using this dot for a multiply sign here or an X for a multiply sign, we're going to use parentheses because there's a decimal in this number. It's easy to get mixed up with X being a variable and the multiplication dot looking like a decimal point. So what I'm going to do for 1 1/10 squared, so I'm going to do 1.1 and 1.1, both in parentheses. Now you need to remember that if two parentheses are right next to each other, or you have a number and a parenthesis, that means these get multiplied together. So this is 1.1 times 1.1. Let's review our multiplication with decimals. So we're going to do 1 times 1 and 1 times 1. Put a 0 in for the ones place. We're done multiplying with the ones place. Now we're going to multiply with the tens place. So we'll start here, okay? Or what would be the tens place if we didn't have decimals. We're going to start here. This will be 1, and that'll be 1. You add them up. You have 2 numbers behind the decimal. So I'm going to move 2 numbers from the right in my answer so that I have 2 decimal places in my answer and 2 decimal places in my problem. That gives me 1.21 for the answer, 1 21/100ths for my simplified answer. Over here for number 4, we have 1/2 times 1/2. So 1/2 squared is going to be 1/2 times 1/2. What I would like you to do is multiply that as a fraction, not as a decimal. You could change it to a decimal, and many of you probably already know what 1/2 is as a decimal, and multiply that times itself. I would like you to see you with 1/2 times 1/2. Now remember, we multiply our numerators and multiply the denominators when we're multiplying fractions. Okay, so tell me what that answer would be. Number 5 is order of operations. When we're doing order of operations with exponents, let's remember, this is kind of a review question. Remember that we'll do what's in parentheses first. Then we will square the answer that came in the parentheses. This is a subtraction sign, so then we'll do 5 minus this answer. And the very last thing we do when we have a large fraction bar like this is divide. So we'll find the answer for the top and divide it by 2 for our final answer. You can go ahead and do that one on your own. Number 6. A square kitchen tile has sides measuring 12 inches. So if this was the kitchen tile, we would have 12 here and 12 here. What is the amount of space that each tile covers? When you have the word covers, this is area. And the formula for area is A equals LW, length times width. Okay? Area equals length times width. And when you get that answer, you're going to have it in inches squared. So if this is 12 inches on each side, I can take 12 times 12 and I can come up with a number. But when I take inches times inches, okay, let's look at this. 3 times 3 is the same as saying 3 squared. 4 times 4 is also 4 squared. So inches times inches, which will be what we're doing here, 12 inches times 12 inches, will be inches squared for our label. So when you're labeling this, find your area, length times width, and it will be in inches squared for your label. I'm going to back up just for a second here. When we have 9 times 9, we could draw this as a picture. Okay? We have a square. We're doing squared here. We have a square. It's 9 on one side and 9 on the other. Length times width will be 9 times 9, and the area of that is 81. All right? Over here, if this were being squared, okay, you'd have -7 on this side and -7 on that side. You take length times width, and you would come up with the area of that square. So when we're talking about models now, we're talking about the length of the sides of a square, multiplying them together to get the area. Something new that you're going to be learning about is square roots. So when we take a number times itself, for example, 8 squared is 8 times 8, and that is 64. 64 is the perfect square of 8. Okay, so 64 is the perfect square of 8. So this has its own terminology, perfect square. Well, we have our base numbers 8 and 8. We call those square roots. Okay, just like if this was 8 times 8 is the plant, and it's going to grow up into a tree to make 64. Okay, so here's our tree. Our perfect square is 64. Its roots are 8 times 8. So the square root of 64 would be 8 squared. 8 squared makes 64. Our square root is 8, just one of them, okay? So the square root of 64 is 8. I'm going to write square root here. Okay? So it's what you start with to make a perfect square. We start with the number 8, and when we square it, we get 64. So 8 is the square root, 64 is the perfect square. We could also have -8 as the square root of 64. And I want you to tell me why that is. Why does 64 have 2 square roots? Why does any perfect square have 2 square roots, both positive and negative? Tell me why you think that is. All right, so now here we go. We're going to find the square roots of these perfect squares. For now, we're only going to talk about the positive square root. We're not going to worry about the negative. You just need to know that there is a negative square root. We're going to talk about the positive square root. It's also known as the principal root of the number. To find a square root, we have to figure out what number do we multiply times itself to make what's inside our square root symbol. This little symbol here, it looks like a check mark with a top. It almost looks like a division sign, but it's not. It's got this little extra piece down here on it. This means what is the square root of 100? Okay, so we need to find the square root of 100. Right now we're working with just perfect squares, so it's going to be a nice whole number. If we thought about this, here's our square. 100 is the area of our square. Okay? Some number is going to go here and here for our length times width, and it has to be the same number, x and x. It's going to be the same number multiplied together to make 100. If I multiplied 50 times 2, I could get 100, but when I draw 50 and 2 for a shape, I don't get a square. I get a rectangle. And what I need, because 100 is a perfect square, I need the numbers I multiply to make a square length times width. So for example, on this one, I know that I can write out 8 times 8 is 64. 9 times 9 is 81. I'm getting closer to 100 here. Now 10 times 10 is 100. Okay, so I could put a 10 here and a 10 here and do length times width and get 100. So the square root is 100 for this, or I'm sorry, 10. The square root is 10. If we had our tree, we'd do 10 times 10. These are the roots, and it's going to grow up into a tree. When we square it or multiply it together, it will make 100. Okay? So this square root is 10 here for our final answer, and I'll put that in red, final answer. All right, so what I want you to do then is tell me what number can you multiply by itself times itself to get 625 for the area. I know I can do 5 times 5 times 5 times 5 and get 625. But I need a square. I need two numbers only, x times x, the same number. What two numbers are the root of 625 that when they're multiplied together, they will give me 625. The same thing for 169. A length times width, that's the same number to give me 169 in the middle of my square. All right. So that's square roots. That's that little funny division symbol there. Which model represents 9 squared? Which number represents 9 squared, or which model represents 9 squared? And one thing that might help you, if you square 9, which is 9 times 9, you'll get a certain number. And the model should have the same number of pieces in it that the answer to 9 times 9 has. Number 5, this word problem. This is your sign. It's a square sign, or it's supposed to be square. If the area of the sign is 576 square inches, then we'd put our 576 in here, inches square. If it's 576 square inches, what are the dimensions? What are the sides worth? What are the side lengths? Okay, if it's a square, it's got to be the same on each side. So tell me, what number can you multiply times itself to get 576? Okay, we're going to talk about this and review this a little bit more in class tomorrow, or when you next have class. So we'll work on that some more then. If you have any questions, we'll answer them then.